yesterday, and now we're learning that scientists and researchers are looking at how to change the weather on purpose. That's right. Lasers now could one day manipulate rain and lightning. CBS This Morning contributor Michio Kaku is a physics professor at City College of New York. Professor, nice to see you. Extraordinary seeing Al Gore and Bill Clinton there together with Charlie, wasn't it?
That's right, yeah.
Yeah, they did not get into this discussion, though. But it is fascinating. I mean, lasers, really, to change the weather?
That's right. Well, as Mark Twain once famously said, everyone complains about the weather, but no one ever does anything about it. Well, instead of doing a rain dance, we physicists are firing trillion-watt lasers into the sky to actually precipitate rain clouds and actually bring down lightning bolts. This is potentially a game changer.
But this is experimental.
It's experimental. However, in the laboratory so far it works. When you have water vapor and you have dust particles or ice crystals, you can precipitate rain. It condenses around the seeds. These seeds can also be created by laser beams. By firing trillion-watt lasers, you rip apart the electrons, creating what are called ions, and these ions act like seeds, like dust particles, bringing down rain and even lightning.
Go ahead.
Well, this fascinates me in part because, too, I remember reading the stories that China had used this during the Olympics, that the USSR had used this after Chernobyl to create rain clouds. I mean, did those really work then? We have some of these capabilities now?
Inconclusive. Even in the 60s, the CIA used this to bring down monsoons during the Vietnam War, to wash out the Viet Cong. Governments have been playing with this thing.
Alleged to.
Alleged to, right.
Yeah.
Now, we realize that for decades now, these governments have been alleged to have experimented with weather control, but nothing conclusive. This time we're bringing in the laws of physics rather than simply waving our hands and uttering mumbo jumbo. We're actually using trillion-watt lasers now. And in the laboratory, sure enough, they precipitate rain out of water vapor. Sure enough, you can actually bring down electricity down the beam.
So what does it mean for drought areas that need to have rain for crops? And if they don't have them, there's the consequences of famine.
Well, the bad news is if it's a clear blue sky, it's not going to do anything at all because it only takes water vapor that's already in the air and condenses it. However, for floods, for agriculture, farmers, for people planning wedding parties, football games, you name it, outdoor events and agriculture and flooding and even hurricanes, all of them could be subject to weather modification.
Incredibly interesting. Professor Michio Kaku, thank you so much.
In the 60s, the CIA used this to bring down monsoons during the Vietnam War, to wash out the Viet Cong. Governments have been playing with this thing.
Alleged to.
Alleged to, right.
By any definition of the word, the United States is an empire today. It's huge, it dominates the world, it has its way, nobody's able to challenge it. Whatever it says is good for the world, that's what the world will do. That's not to say that everything it does in the world is bad, but it is to say that it can do whatever it chooses, good or bad, and no one dares say it's bad. The United States has all of those elements of empire, including one that many people don't even think about. And that element is that all empires come to an end.
It gets remains to be seen. But the notion that cloud seeding is proof of, quote, chemtrails, which is the paranoid hypothesis that jets are being instructed by elites to spray everyone with chemicals, is foolish and logically inconsistent. Because wouldn't the malevolent pilots all over the world have the foresight to understand that they too exist under the clouds that they're spraying on everyone? It's the equivalent of trying to sink the Titanic, only you're still on it and the Titanic is the world. And if chemtrailers cared so deeply about not wanting to inhale chemicals, wouldn't they be protesting refineries? If your concern is breathing in pollution, the place to start would be the factories that are transparently emitting benzene, formaldehyde, mercury, and radon gas everywhere. One doesn't need a conspiracy to know that our air sucks. But with all that said, are there other factors of geoengineering we should be worrying about? And how on point or off are those on the fringes who claim they have evidence that some are using or trying to use the weather with a much more sophisticated level of control, and who are doing so with either misguided or even sinister intentions?
This summer?
This summer.
You succeeded in increasing rainfall?
South of San Antonio, we had aircraft flying on a dozen days in the month of July, treating what we deemed to be seedable storms.
And what was the result of that?
The same result that we've seen since it started in 1997. Some clouds respond very well. Some clouds respond only to a limited degree. Maybe one or two instances when clouds didn't respond as we had hoped, probably because we got to them too late.
And when you say they responded very well, what does that mean?
It means that the storm lived longer and produced more rain over a larger area.
And how do we know that it did that? I mean, what if you hadn't seeded? I mean,
good question. We know that because we systematically analyze on a given day clouds that are seeded, and we compare their behavior with similar clouds in areas adjacent to the target area that were not seeded. And we compare the behavior of the two sets, the treated and the unseeded. And we've been doing that for about 10 years now. And we have seen a very consistent response from storms that were seeded in a timely fashion.
operation.
Is the array of technologies, often referred to collectively as geo-engineering, that potentially could help reverse the warming effects of global climate change. One that has gained my personal attention is stratospheric aerosol injection, or SAI, a method of seeding the stratosphere with particles that can help reflect the sun's heat in much the same way that volcanic eruptions do. An SAI program could limit global temperature increases, reducing some risks associated with higher temperatures and providing the world economy additional time to transition from fossil fuels. This process is also relatively inexpensive. The National Research Council estimates that a fully deployed SAI program would cost about $10 billion yearly. As promising as it may be, moving forward on SAI would also raise a number of challenges for our government and for the international community. On the technical side, greenhouse gas emission reductions would still have to accompany SAI to address other climate change effects, such as ocean acidification, because SAI alone would not remove greenhouse gases from the atmosphere. On the geopolitical side, the technology's potential to alter weather patterns and benefit certain regions of the world at the expense of other regions could trigger sharp opposition by some nations. Others might seize on SAI's benefits and back away from their commitment to carbon dioxide reductions. And as with other breakthrough technologies, global norms and standards are lacking to guide the deployment and implementation of SAI and other geoengineering initiatives. Now, I could go on and on and on and on about the things that fascinate me, but rather than talk about them, I thought I'd stop here and start the conversation with Judy, and then I can take some of your questions. I very much appreciate the invitation to come back here in the Council on Foreign Relations, and as I say to all the groups I speak to, it is a tremendous honor and privilege every day to be referred to as the Director of Central Intelligence Agency. I lead an organization full of patriotic men and women who take great risks and put themselves on the front lines in order to keep their fellow Americans safe and secure, and to do what they can to keep this country's security secure. Thank you so much.
All of you this morning, very interesting. I wanted to ask a couple questions here about HAARP, the High Frequency Active Auroral Research Program. Several of you at the table have a little bit of a piece here. As you know, this is located up in Alaska. It's currently funded by the Air Force Research Lab. It was formerly funded by the Office of Naval Research. One of the prime customers is DARPA, which is currently running experiments at the facilities here. So questions to several of you this morning. I'm told by the president of the University of Alaska that the Air Force has pulled its support for the facility, and they're taking steps to demolish it or take it down this summer. He's making the argument that there is other opportunities for us, and is trying to find a path where the university might be able to take title to the facility. I'd like to start with you, Dr. Prabhakar. I understand that a lot of folks here on the committee probably don't understand what HAARP does. I think most Alaskans don't really know what HAARP does or why the agency is involved in it. So a very brief explanation, and then a more direct question. Would you be disappointed, or would you lose something if HAARP were to go away?
Senator Murkowski, as I think you know, one of our programs has been using the HAARP facility for the research that it's pursuing. And my understanding is that we did get value out of that interaction. The P in DARPA is projects, and we're not in the business of doing the same thing forever. And so very naturally, as we conclude that work, we're going to move on to other topics. So it's not an ongoing need for DARPA, despite the fact that we had actually gotten some good value out of that infrastructure in the past.
Understood. Then to Dr. Walker and Mr. Schaefer then, Dr. Walker, your agency is currently running the facility. I've mentioned that it's our understanding through the president of UAF that the plans are to move forward and demolish the facility this summer. So the question to you is that accurate? Can you explain why? And then perhaps to both you and Mr. Schaefer, is there any benefit in exploring a potential relationship with the University of Alaska to perhaps take over the HARP?
Thank you, Senator. The Air Force has gotten great value out of HARP in the past. We took over from the Navy and managed it and actually did a number of experiment campaigns up there and have finished our work that we're interested in doing up there. We've moving on to other ways of managing the ionosphere, which the HARP was really designed to do, was to inject energy into the ionosphere, be able to actually control it. And, but that work has been completed. The Air Force has maintained the site for other government agencies to use for several years now. And with DARPA completing their project, that's our last government customer that we have in the site. We have put out a call government-wide for other agencies that had interest in managing the site or taking it over, and including going out to academia and seeing if there was any interest there. We have gotten interest from the university in Fairbanks. However, the interest we have is that they will run it if we fund it, which is unfortunately in this fiscal environment we're in right now, this is not an area that we have any need for in the future and don't see that it would be good use of Air Force S&T funds in the future. So our position has been that if there's not somebody who wants to take over the management and the funding of the site, then the Air Force has no future need, and that we do plan to do a dismantle of the system in the future after we make appropriate notifications.
When you say in the future, do you anticipate that it would be this summer then, or would there perhaps be more time for the university to try to figure something out?
We would prefer to start this summer. We would like to get the critical equipment out of the site before the winter. The harsh winter in Alaska does lead to a very costly winterization to maintain the site, and we'd like to avoid that if we can.
Okay. Mr. Schaefer, if you have any comments on that?
Yes, ma'am. So I'm torn on this because my background is as an atmospheric scientist, and I think the facility is just a world-class facility. That said, we've worked very hard with the Air Force, with the Office of Science and Technology Policy over the last 18 to 24 months to find another sponsor for this, because it really, as you've heard the other people at the table, we, the department, have gotten the research value out that we need for the facility. We've also worked with University of Alaska Fairbanks to get some other person to pick up the long-term, just pure scientific research that HARP offers the promise of. But with all the other issues and problems and challenges facing the department at this time, we just don't see that investment over a long-term period is where we would prioritize our investment. So we've been working with other agencies, trying to get agencies
Is time travel possible? Are there other dimensions? Are there parallel universes? We can get hints, glimmers of these cosmic questions with this machine.
So you think we can figure out what happened before the Big Bang You think we can figure out whether or not time travel's possible because
right.
of what they're doing on the French-Swiss border?
That's right. We're going to find not just particles. We're going to try to prove a theory called string theory, which is what I do for a living. String theory exists in 10, 11-dimensional hyperspace and other dimensions, and it actually says that maybe our universe was created by the collision of two other universes. And maybe our universe is a bubble of some sort, and there are other bubbles out there, other expanding and contracting
And what would
bubbles.
these other bubbles mean to you?
These are other universes where perhaps there could be other laws of physics. I mean, this is huge.
Really?
This is greater than the Copernican revolution, when we realize that there are stars and
Holy cow.
and galaxies out
We've
there.
been bringing you on for 3 years. You've never talked like this before.
Well, this is what I do for a living. Some people think it's too hard to understand, but I think the average person can realize, hey, these are words you hear in Star Trek, right? These are concepts you hear, but no one ever works on these things. That's what the Large Hadron Collider
So
comes
you're
in.
putting this up there with Sir Isaac Newton in gravity. You're putting that up there with Thomas Edison in electromagnetism.
That's right.
You're putting that up there with Albert Einstein and E equals MC squared, which led to nuclear power.
Right.
That's what you're writing about today in the Wall Street Journal.
That's
It's
right.
that significant?
It's that big. We're talking about unifying all the forces of nature. There are 4 forces that make the world move. Each time a force was unraveled, it unleashed the Industrial Revolution, the Electric Revolution, and now the Nuclear Revolution. And now we have a super force that we're going to try to unravel, which created the universe.
But what does that lead to? Do we know yet?
We don't know yet. Now, in the short term, people say, will I get better color television? Will I get better internet reception?
Cell service?
Yeah. And the answer is no. These are cosmic questions that don't impinge directly on our lives.
All right, now listen, I read your piece today in the Wall Street Journal. Well done, by the way, and I recommend it to viewers at home. You wrote about something in here that I never knew. Ronald Reagan approved this to be built outside of Dallas, Texas.
Right.
They spent $1 billion, dug a giant hole, and nothing happened.
Right.
In 1993, they spent another $1 billion and filled in the hole. And now all these physics professors who are conducting these experiments in Europe, it could have been happening here at home. And you're suggesting there's a bit of a brain drain from the United States to Europe to pursue projects like these.
Right. This machine could have been our machine. Ronald Reagan wanted a machine 3 times bigger than this pea shooter in Geneva, Switzerland. But Congress canceled it, and now the Europeans are creating the new Vatican of physics. Physicists are leaving the United States to go to Geneva, Switzerland. They get this brand new machine, and what do we get? We get a $2 billion hole.
Who made that call?
The United States Congress canceled the machine over the objections of President Ronald Reagan.
We don't like being number 2, but we like having you. Michio, thank you. Michio Kaku with us today. Fascinating
so
stuff.
$1 billion to dig the hole.
Yeah.
To build this, so we can do it here at home.
Fill in the hole.
Then $1 billion decision by Congress, fill it in.
Yeah.
And now brain drain to
That's
Europe.
what we get.
Of all places.
They get the machine, we get a hole.
Wow.
Yeah.
That's interesting. That's interesting to cook over. Thank you very much, Michio. Thanks, Bill. All right.